In this video, we'll generate the Pascal triangle coefficients using the LINEST Polynomial Regression and the Taylor-Maclaurin SERIESSUM expansion. We'll generate the dataset of the binomial series where our values of x is from -1 to 1. So this is and our values of k is 0 to 6. So data validation, list of items 0 to 6. That's our k values from 0 to 6. So it's 3 here. And our binomial series 1 plus k, 1 plus x to the power k is RA formula. 1 plus x to the power k. And we'll chart this. Using scatter chart and show the trend line. Polynomial to the degree 6. Show the equation as the label. And we'll move this downwards for comparison with our regression coefficients. We'll move it at the bottom. So here we have the trend line and the trend line equation, which is a polynomial to the degree 6. Because our maximum here is 6. So if this is 1, we'll just increase this to okay. So if k equals 1, so we have the polynomial 1 plus 1x. So this is the Pascal triangle coefficient 1, 1. And we'll generate also the Taylor-Maclaurin SERIESSUM expansion. So this is our formula, series sum of the x values. The definition of this is the summation of a times x to the n, where a is a combina of k minus n plus 1 comma n. And our n will start from 0 to infinity. So 0 to infinity. And the interval is 1. And the coefficient will be this range. And we'll work on the values of n. That's 0 to infinity. 0 to infinity. So let's say this is 3. This is how it's gonna look like. The red trend line will show the trend line as well. Polynomial to the degree 6. And show it as equation. So we have the trend line and trend line equation of the Taylor-Maclaurin SERIESSUM expansion. Now we can work on the coefficients, which is RA formula, COMBINA. Inside the COMBINA is k minus n. So that's k minus n plus 1, comma, n. That's inside the combina. So we have an error. This should be 0 because this is only for good only if k is 3. If it's greater than 3, it should be 0. So we have to correct this. So if if n is greater than 3k. So if n is greater than k, 0. Otherwise, combina. Now it's correct. So if it's greater than k, this should be 0. Now we can continue with 4. So we have the coefficients of the Pascal triangles. So 1, 4, 6, 4, 1. 1, 4, 6, 4, 1. That's the Pascal triangle coefficient. We'll calculate these regression coefficients using LINEST polynomial regression. To do that, we will complete the 1 comma x matrix. So here we have the power, which is transpose from 0 to 6. Now that we have the power, we can enter the 1 comma x matrix. So array formula of the x values raised to the power 0 to 6. Now that we have the 1 comma x matrix, we can enter the LINEST. LINEST data y and data x. And our regression coefficient match to our expansion coefficients. And the trend line 1, 4, 6, 4, 1. Others are 0. Then we enter the LINEST for the Taylor Maclaurin SERIESSUM expansion, which is LINEST data y and data x. So our regression coefficient match to our expansion coefficients and our trend line equation. So the polynomial 1 plus 4x plus 6x squared plus 4x cubed plus x to the fourth. We will now compare this with the Pascal triangle, starting with 0. At k equals 0, y equals 1, and this is y equals 1. So is y equals 1, and this is 1. At k equals 1, so our polynomial is y equals 1 plus x. So y equals 1 plus x. And these regression coefficients match to our expansion coefficient and the Pascal triangle coefficients. At k equals 2, our polynomial is y equals 1 plus 2x plus x squared. All these are 0. So 1 plus 2x plus x squared. And these regression coefficients match to our expansion coefficients and the Pascal triangle coefficients. At k equals 3, our polynomial is 1 plus 3x plus 3x squared plus x cubed. All these are 0. So that's 1 plus 3x plus 3x squared plus x cubed. Our regression coefficients match to our expansion coefficient and this Pascal triangle 1, 3, 3, 1. At k equals 4, our polynomial is 1 plus 4x plus 6x squared plus 4x cubed plus x to the fourth. 1 plus 4x plus 6x squared plus 4x cubed plus x to the fourth. This regression coefficient match to our expansion coefficient and the Pascal triangle 1, 4, 6, 4, 1. At k equals 5. K equals 5. Our polynomial is 1 plus 5x plus 10x squared plus 10x cubed plus 5x to the fourth plus 1 or plus x to the fifth, and this is 0. So 1 plus 5x plus 10x squared plus 10x cubed plus 5x to the fourth plus x to the fifth. our regression coefficient match to our expansion coefficient, and our Pascal triangle 1, 5, 10, 10, 5, 1. And at x equals 6, so our polynomial is 1 plus 6x plus 15x squared plus 20x cubed plus 15x to the fourth plus 6x to the fifth plus x to the sixth. That's x 1x plus 1 plus 6x plus 15x squared plus 20x cubed plus 15x to the fourth plus 6x to the fifth x to the sixth. The regression coefficient match to our expansion coefficients. This completes the generation of the Pascal triangle coefficients using the Taylor-Maclaurin series sum, expansion, and the LINEST